Hello everyone, welcome to my YouTube channel. My name is Eliseo Junior M. Bernardo from BSED Math 3A. In this video, we will talk about task number 2, which is the explore its subgroups and draw a lattice diagram relating different subgroups. So in this table, you get it from task number 1, the table of our 16 movement or 16 symmetries, and in this task, we need to identify it or explore its subgroups. So you have improper subgroups, proper subgroups, and trivial subgroups. In improper subgroups, under improper subgroups, we have A1. Um, it contains all the elements of the group or the set itself. And in proper subgroups, we have A2, A3 to A14. The proper subgroups contains elements that are less than the number elements from the group and greater than one element. And lastly, trivial group. Under trivial group, we have A15, which is R, the identity element. So trivial subgroup contains the identity element. So under improper subgroups, we have the set itself. In previous task, we already identify this set is a group because it is closed, it has associative, it has identity element, and it has inverse for all elements, therefore it is a group and it is the subset of all group. And in improper subgroups, you have A2. In A2, we have the element R, R1, R2, R3, R4, R5, R6, and R7. As you can see here, we have the table. And in checking the associative of the table, we have to rotate it 180 degrees. So in checking the subgroups, if it is group, it, we need to identify if it is closed, it is associative, it has identity element and inverse. So in this table, it is closed, and it is associative because even though we rotate it 180 degrees and interchange the rows and columns, we get the same structure on the original table. So you can see here, the original table in 180 degrees, we rotate it 180 degrees is the same as the original. So since all the conditions in a group has been satisfied, we conclude that A2 is a part of subgroup. And in A3, we have R, R2, R4, R6, M2, M4, and M6. And we construct with the original table since it is closed. And in checking the associative, we rotate it 180 degrees. It is associative because even though we rotated it and interchange its rows and columns, we still get the same structure of the original table. And that's the identity, it has the identity element R, and its inverse. The inverse of R is R. Inverse of R2 is R6. The inverse of R4 is M4. The inverse of R6 is R2. And M is and its inverse is M2 inverse is M2. M4 inverse is M4, M6 inverse is M6. Since all the condition in a group has been satisfied, therefore A3 is a part of subgroups. And let's proceed to A4. We have R, R2, R4, R6, M1, M3, M5, and M7. And we construct the original table and rotate it 180 degrees. And we check it, it is closed. It is associative because even though we rotated it and interchanged the rows and columns, we get the same structure to the original table. And it has the identity element R. The inverse is R. The inverse of R is R. The inverse of R2 is R6. The inverse of R4 is R4. The inverse of R6 is R2. And The reflection movement is their inverse is themselves. Hence, all the condition has been satisfied. We conclude that A4 is a part of subgroup. And in A5, we have R and R4, M and M4. And we extend the table and we rotate it 180 degrees to check if it is associative. Since it is close, let's proceed to associative because if we rotate it 180 degrees interchange its rows and columns, we could get the same structure in original. And it has the identity element R, and its inverse R, R4 is M inverse is M, and M4 inverse is M4. Since all condition has been satisfied, therefore A sub 5 is part of subgroup. Let's proceed to A sub 6 or A6. We have R4, M2, and M6. Same same procedure on the previous um proper subgroups. We check if it has close associative identity. So all condition has been satisfied. Therefore, we could say that A6 is a part of subgroup. Same as A7, A8, A9 to A10, and A14. Let's proceed to A14. Okay. So A2 to A14 is group. And let's check if the trivial group is a group or is it a part of subgroups, and it is close associative. It has identity element which is the R itself and has inverse element. Since all the condition in a group has been satisfied, we conclude that this set is a part of subgroup. And this is the lattice diagram. You have the A1 is in the top and A3, A2, A9, sorry, A4 rather, and A5, A6, A7, and A8. This is the A9, A10, A11, 12, 14, and A8, 12, and 15. The A15 is in the bottom. And here's the latest diagram of the subgroup of A. And it shows the connection of the improper subgroups to trivial. As we can see the diagram, the elements of proper subgroup as elements on A2, only few elements which all elements are in the set of A2 to A11, followed by the other subgroups with only two elements that are in A5 to A7, and doon to trivial subgroup which is A15. So that's all. Thank you for listening. Once again, I'm Elise Juni and Bernardo from BSED Math 3A. Thank you for listening.